Rover X is officially finished. Again. Today I'm showing you the full build, the wiring, the exact Arduino code, and then a live obstacle avoidance demo using the ultrasonic sensor, two continuous rotation servo motors, an LED, and a buzzer. Also, if you're building this with students, pause and rewatch as needed. We go slow now so you can go fast later. I'm Dr. P, and this is Dr. P Learning. Most rover builds fail for one of three reasons. Wiring is messy, servo directions get flipped, or the logic doesn't match what the robot is actually doing. I'm going to show you how this code makes Rover X do one simple job really well. Drive forward until it sees something, then back up, arc away, and continue.
Here is what we will be working with for this build. A microcontroller, I'm using an Elegoo. You can also use an Arduino R3, an ultrasonic sensor. The trigger will be on pin 7 and the echo on pin 8. We're also using an LED on pin 13, a buzzer on pin 4, two continuous servos, the left one on pin 9 and the right one on pin 10. Here's the pro tip. Keep your grounds common. The sensor, the buzzer, the servos can all be grounded to the same ground reference. And now it's time for the code walkthrough. Up top, we include the servo library and define the two servos. L servo is left and R servo is right. We also define pins for the sensor, LED, and the buzzer, right? Next, we have the entire brain of the rover. This is the constant threshold of 40 centimeters. So if the distance is greater than 40 centimeters, we treat it as a clear and go forward. If it's 40 centimeters or less, we trigger the obstacle routine. Teachers, this is a great moment to talk about how tuning thresholds changes the rover behavior. Next, we attach the servos, the left servo to pin 9, the right servo to pin 10. The trigger is set to output, the echo is set to input. The LED and the buzzer are both set to outputs. Okay, and then we'll set the LED to a low state and then no tone for the buzzer. Okay, in the loop, we use the trig pin, low for 2 microseconds, high for 10 microseconds, and then a low. Then we read the echo duration, okay, using centimeters. Distance centimeters equals duration is a classic shortcut for the timing and the distance in centimeters. Okay. All right, if the path is clear, the left servo writes 165, the right servo writes 15. That is your forward drive. LED stays off, buzzer stays silent. That's important because robots should give feedback but not scream when everything is fine. So motor speed is controlled by how much signal we send to the motor. More signal equals faster spin, less signal equals slower spin. With continuous rotation servos, speed is controlled by the number we write to the servo. Around 90 is stop, so numbers above 90 spin one direction, numbers below 90 spin the other direction. The further away from 90, the faster the motor spins. For example, 165 is spin forward fast. 1 is a slow reversed. 15 is a fast forward in the opposite direction. So think of a motor speed like a gas pedal. The further you push away from the stop value, the faster the motor spins. So 90 is parked, close to 90 is creeping along, and far from 90 is flooring it. Okay. When the ultrasonic sensor detects an object less than 40 centimeters, the LED turns on, the buzzer hits 2000 Hertz immediately. It does a backup and right arc for 2 seconds, so left servo is 10, right servo is 100. Okay. Then it does a left pivot for 2000 milliseconds or 2 seconds. So left 20, right 15. Because this servo is flipped over, you have to flip over the code as well. Okay, then there's a tiny delay of 10 microseconds. Basically nothing, but it's there. Then it goes back to forward drive, turns off alerts, and adds a small cooldown delay so it doesn't automatically re-trigger on the same object. Okay. This is a clean example of a state machine without overcomplicating it. A clear state versus an object state. A clear state is when the robot senses no obstacles and continues normal forward movement, while object state is when the robot detects something in its path and switches to an avoidance behavior.
Now we are on to the wiring part of this Rover X. We're going to take our ultrasonic sensor and place it on the second row. Place it on the second row, that way the bottom of the sensor has some stability on the breadboard. I have this wire pin here connected from ground here, and what I will do is I will connect the ground, it's marked on the bottom here, of the buzzer to that row. Remember, that entire row is connected, and the power is on row, the plus is on row 25. Now from the code, we use pin 4, so we will plug this into pin 4. Alright. The power on the ultrasonic sensor is on this pin on this side, so we will plug the power from here to our plus on this side. We will plug the ground from the ground is on the opposite side on the ultrasonic sensor. We'll plug that there, and we'll comment our ground there. All right. Okay. The echo is next to the ground, and that is going to be a yellow wire. Okay. All right. Echo is on pin 8. I'm just double checking. So pin 8 is right here. We will plug that in there. The trigger is green. All right, and that is on pin 7, which is right next to pin 8. All right, so far so good. Our left servo is on pin 9. So there's our white wire here, pin 9. And our right servo is on pin 10, which is right next to that. I will move this over so that you can actually see pin 10 there. Right. Our LED was already plugged in. Remember that the 13 and ground are right next to each other. So the long stem of the LED into 13 and the short stem into ground. All right, we're almost there. We're using common voltage for common plus for the servos, common ground for the servos. I'm just going to slide this pin over for the ultrasonic sensor. Common ground
common power. Now, as far as this side is concerned, we're all done. The only thing that we really need is the ground from the microcontroller to the board, which is there, and the power, or your 5 volts. It's a little tough to see, but right there, 5V. We're going to plug this in here, and we are power right over here. And voila! Now on to the fun stuff. It's time for a rover demonstration. So it's going back 2 seconds and then it spins out for 2 seconds.
If you want the full Rover X curriculum, student handout, wiring diagrams, and challenges, click the links in the description. Like the video and comment Rover if you want me to add a scanning servo head. I'm Dr. P. This is Dr. P Learning. Have a wonderful day.